For today's video, we will going to discuss the video tracking. So what is video tracking? Video tracking is the process of capturing and analyzing the video feeds frame by frame of a particular object or a person over a short time interval. It is used to measure and analyze movement, visual attentions, as well as behaviors. Video tracking is used for customer identification, surveillance, augmented reality, traffic control, and medical imaging. It is yet another mechanism to identify and monitor things when sensors or RFID tags are not available. Video tracking may also be used in conjunction with sensors and or RFID to provide a more comprehensive solution. Unlike pre-installed sensors and RFID tags in things, video tracking can be turned on instantly. However, video tracking does have a major weakness with today's technology. Video tracking is often time-consuming. It requires analyzing large amount of video traffic and, in many cases, correlation with historical data to arrive at accurate conclusion. Another challenge to video tracking is complex objects image recognition techniques. This is a huge area of research in machine learning today. Video tracking applications. Video tracking applications are applicable for retailers. Many retailers have started using video tracking solution, often in a conjunction with the Wi-Fi access point data, to increase sales and provide a better service for the customers. Video tracking is analyzed using complex algorithm that tracks eye movement and identify fixation, for example, the desirability, obsession, and attraction to a product, and a glissade, wobbling movements. The collected data is then filtered against well-established business rules to determine an internal action, for example, the change location of merchandise and more checkout lines, or example, the actions offers the customers a certain discount. Determining the business rules is a very challenging problem. Many companies use advanced systems and techniques, for example, the machine learning, analysis of social media data, and artificial intelligence, or hire a marketing firm to survey a large number of customers to arrive at such rules. Example of a new rules is the fact that the faster a shopper finds the first item she or he needs, the more she or he purchases in such category. This dispels the previous myth that the more time a shopper spends in a particular area, the more she or he buys. Video tracking is also used to improve the overall shopping experience in the store as a service differentiation, especially if the store is a bit more expensive than a similar store in the area. The analysis of multiple grocery store traffic indicates that customers did not mind paying a bit more for faster checkout lines with a friendly cashier, bright lights, and clean bills. Analyzed data also indicated that the vast majority of customers do not pay attention to interval signs inside the store. Video tracking also apply in the banking. Similar to the retailers, banks have also started using video tracking solutions, often combined with the Wi-Fi data. Access to Wi-Fi data in banks is easier given that the most of customers downloads the bank mobile app on their smartphones. With the right setting, mobile app often allows the bank to track the whereabouts of the customers. Bank use the data to quickly identify the customers, often before the lines in the queue, depending on the priority of such customers. Example has a large sum of money deposited at the bank. Especially greatly may be zero-wait private service if offered by the bank manager. Other uses of video tracking may apply in advanced back-end analytics are unlimited, ranging from physical monitoring and security to traffic management and control and argumented reality, where an actual view is augmented by a computer-generated sensual input such as video. Video tracking algorithm. To perform video tracking, an algorithm analyzes sequential video frames and outputs the movement of target between the frames. There is a variety of algorithms, each having its own strengths and weaknesses. Considering the intended application is important when choosing one algorithm to use. There are two major components of a visual tracking system. First is the target representation and localization, and the second one is the filtering and data association. Target representation and localization is mostly a bottom-up process. These methods give a variety of tools for identifying the moving object. Locating and tracking the target object successfully is dependent on the algorithm. For example, using the blob tracking is useful for identifying human movement because a person's profile changing dynamically. Typically, the computations complexity for this algorithm is low. Following are some common target representation and localization algorithm. First is the contour tracking, which is a method iteratively evolved an initial contour initialized from the previous frame to its new position in the current frame. This approach to control tracking directly evolves the contour by minimizing the contour energy using gradient descent. And the last one is the Kalman filter. Kalman filter is an optimal recursive Bayesian filter for linear functions subjected to Gaussian noise. It is an algorithm that uses a serial of measurement observed over time, continuing noise, random variation, and other inaccuracies, and produces estimated of unknown variables that tend to be more precise than those based on a single measurement alone. And that could be all. Thank you.